Hello everybody, welcome to another CS Lightwork video. I hope you guys are all doing well, and today I'm bringing you guys a tutorial / explanation on the bubble sort algorithm. Now I think this is a very important algorithm to learn. It's one of the first ones you learn once you start getting into computer science, and essentially while it may be simple for those who are already familiar with it, it serves as a good base and stepping stone into the realm of creating algorithms. Now, those of you who are unfamiliar with the bubble sort, don't worry, the syntax is pretty simple, and we're going to go through in this video not only the code and how to write it, but the functionality of the sort and how we're actually deciding what to sort, what to switch in the list, so that way you guys have a better understanding of the bigger picture rather than just the code. Alright, so what is the bubble sort specifically? What does it do? How does it function? So the bubble sort is typically made to take some sort of input list, so that could be a list of numbers, an array of numbers, etc. And the goal of this algorithm is to return it greatest to least or least to greatest. And how it does that is it looks at two values at a time and switches them if need be. Now I know that can sound a little confusing, don't worry, it took me a while to get to at the beginning. But once I draw this out with some test data, it might be a little easier to explain. So let's give ourselves a test list. Let's say 5, 64, 32, 2, 3, and 1. Now this data is completely random. The goal of this is to have an unsorted list so that we can sort it using the algorithm. So let's look at this list. Say we set a goal in mind, we want this to be ordered from least to greatest. How does the bubble sort approach this? Well, as I mentioned before, it looks at two value pairs at a time. Now, what does this mean? Don't worry, I got you. So let's start with the first two. What the bubble sort does is it looks at the first value and looks at the second value and checks if a switch is needed to be. So as I said before, let's say we're trying to make this list least to greatest in numerical value. What we would do is we're looking at 5 and 64. Do these need to be switched? No, because the second value is bigger than the first value, and that's exactly what we want. Moving on. Now, we keep going through the list as such. So now we look at 64 and 32. The second value we're looking at is smaller than the first value. So the bubble sort algorithm is essentially going to do a little switcheroo right there. So what's it going to do? It's going to swap the second element with the third element. In terms of code, that would be index value 1 with 2. So as you can see, the swap is made right here. I'll just do an arrow down. Now again, we look at the same thing. We've looked at these two, and we keep going. So 64 and 2. Do these need to be switched by the same logic? Absolutely. So now we have this list, and that's just going to turn into 2 and 64. So now again, by the same logic, let's look at the next two, and as you can see, 3 and 64 need to be switched because we want the bigger number at the end. So again, one more time, when we do this, we're going to now have 3, 64, and so forth. You get the idea, and then one final switch will take place, and now we have 64 at the end, 1 over here, and 3 over here. Now we went through the list one time. Now, you may be thinking, this list isn't sorted. You're absolutely right. So how the code works is after it goes through one iteration, to make sure that it's still not unsorted, it will go through once more. And if it finds any pairs that aren't in the right order, it will cause it to go through once more. So what does that mean? I know it sounds a little confusing, don't worry. So what this means is what the code does, it will always check after it run throughs once. So here we ran through all the way, and it's going to check one more time. And in this case, it needs to, right? Because the 64 and 1 makes sense, but this 1 should be all the way back here, same with the 2 and 3. So what it does is it goes through again. So once it goes through again, as you can see, the 32 and 2 will end up switching because we're looking at 5 and 32, and then it'll switch. And then again, this will be a 32 and a 3, so it'll switch, and then a 32 and a 1, and it'll switch. So what we end up having is, I'll walk through right here, is these end up swapping, so this becomes a 2 and a 32. Then we look again, oh, 32 is bigger than 3, And then we look again, 32 is bigger than 1. So now we have this. Now remember I said, after we iterate through and we find a error, which was the 32 being here, we loop through once again because we need to keep checking. And as you can see, there's still a problem here. This 5 should be later, the 1 should be back, the 2 should be before. So essentially what the algorithm is doing is checking 2 by 2 by 2 by 2, and then checking one more time. And if it sees, oh, there was a mispair, let the code know, hey, there was a mispair, we need to check again, because we always do that final check. So again, I'll walk through this iteration right over here. I'll just draw a little arrow up here. And what it's going to do is, now we'll check 5 and 2. Oh, these need to be switched. Oh, these need to be switched as well, because 3 is ahead, but it should be behind 5. So this becomes a 5, and that becomes a 3. And then, oh, just again. And as you can see, you see where this is going. It found that the 5 was in the wrong spot, so it's letting the code know, hey, we need to look through one more time. Every time we see a pair of 2 in the wrong spots that needs to be switched, we let the code know, hey, we need to check it all over again one more time. And as you can see, it does. So we'll just do that iteration one more time. So as we can see, looking at the older list, that 2 and 3 would stay the same, but the 1 and 3 would swap, right? Because 1 is smaller than 3 and it's ahead, so it would swap. And then the rest would remain the same. And finally, after all these iterations, we will finally get the sorted list, as you guys can see. Because once it goes through that last iteration where the code said, okay, the 5 needs to be, the 3 needed to be switched with the 1, we need to check over one more time. It will finally make that 1 and 2 switch and end up here. So again, I'll go through this really quickly. We were kept looking at pairs of 2 values and swap them if need be. And then every time we got to the end of the array, we said, hey, did we make a switch? If we did, we need to go back check again. And that's essentially how the bubble sort works. This is the process we took, and now we are ended up with least to greatest. If you wanted to do this greatest to least, it would be the same process, but instead of looking at the number ahead wanting to be bigger, you'd want it to be smaller. So then if you were going from greatest to least, you would say, hey, 1 is before, but 2 is bigger, so we want to switch it that way. But essentially, that's how the functionality of the bubble sort works. In terms of time efficiency, it is not the best, but for a beginner algorithm, it's a very good thing to know and understand how the functionality is working. We're switching by 2, and then we're making sure that at the end of the array, we check again if there was a swap until we finally arrive here, where, hey, it will iterate through this final list and say, hey, we didn't need to make a swap. We're good to go. And boom, just like that, you're done. All right, so what does this look like on a coding level when we're looking at Python? Well, first let's declare that same example list we used previously. So that was, let's just call it list in this case. We were using 5, 64, 32, 2, 3, and 1. Now, essentially, we're going to code it up the same way we did it in the explanation. So first, we have to iterate through the entire list, right? We have to keep that in mind. So while keeping that in mind, we have to remember all the concepts we went through. So first, it's going to keep checking the whole list each time there was a switch that takes place. So for that, we might need a value to indicate, is it sorted? Is it not sorted? Do we need to check again? So let's call that sorted. This is going to be a Boolean value, so true or false. Now, of course, we have to assume the list is not sorted when we first get it, right? That's why we'll go into iterating through the list. So we'll set sorted to false. Now we need a loop that essentially is saying, while it's not sorted, we need to keep trying to sort it. So we're going to use a while loop, and we'll just say, while it's not sorted. Excuse the GitHub autopilot, phenomenal add-on. And now here's what we're going to do. Once we get in here, we're going to set sorted to true. And you're like, where's this coming from? Why are we setting it to true? We have done nothing. This is so we can escape the iteration, escape the constant looping if we need to. We're setting it at true at the beginning, but this guarantees we'll have to go in once, right? Because not indicates if sorted is false. So we're going to have to go through it once, but here we're saying, okay, set it to true. And if it's not changed back, boom, no more looping. So that's what we're doing. Now here, within this loop saying, hey, while it's not sorted, do this, we need to actually go through each value of the list, right? So let's do that in a for loop. So for, let's just say, current element in range, and then we're going to loop through the entire length of the list. So this is going to have to be len, which is a function returning the length of whatever list, and we're going to have to do -1, because remember, the last index value is going to be the length of the list -1, right? Because we start at 0. So 0, 1, 2, 3, 4, 5, even though there's 6 in the whole list. So our indexing length is going to be -1. And you might be like, Taseen, that doesn't make sense. It should just be the length of the list, but we'll get into that. So for ease's sake, I'm just going to put this in a variable called indexing length. And again, if I'm going too fast, please feel free to let me know. And now we can just have this in here. So now what we're going to do is we're going to loop through. But remember when I mentioned we're comparing one element and the next? That's where this -1 comes in. Because if we go to all the way to the end and we say, hey, compare one and its next, Python will go to the first one. That's specific to Python. But in general, it'll be an error, right? Because you're looking for the next one at the last one. So this -1 stops us at 3, but will allow us to go to 1. Now, in this list, what do we want to do? We want to compare. So what we need to look at, as we mentioned before, hey, is the first element bigger than the next one? If so, swap. So all we have to do is, if the list element, the current one we're on, so in this case, let's say we're at 5. If that's bigger than the next one, so we can do greater than list current element +1, which is just the next index, right? If it is bigger, swap them. So what we're going to do is swap them. But before we swap them, remember how I said if we need to make a swap, we have to let the code know, hey, we're going to have to run through it again. This is where we set sorted to false. The reason for this is, as you can see, now sorted is false. We're going to have to loop again, right? Because this is going to loop if sorted is false. And here we are. Hey, code, we needed to make a swap, so now we got to set sorted to false. Perfect. Now let's actually make that swap. So in Python, you can swap list elements by simply writing them out next to each other. So list current element, the first one, and then comma list current element +1. That's the next one. And then all we have to do is set it to equal the reverse. So equal list element +1, because we want the one ahead to go to the past one. So we're saying list current element +1. +1 is now going to be list of current elements. So you're essentially swapping, right? And then now all you have to do is exit the loop. Now you guys might be wondering, a little confused on how it's working. So first I'm going to print out the list, the sorted list, and run the code just so you guys are able to see. Ignore clear the terminal for you guys. And as you can see, the sorted list is returned, the same one we saw on the whiteboard. So how is this working on a coding level? Again, we're setting sorted to false, and we're having the max range we touch is the length -1 because we don't want to go over. Now, when we go and we set sorted to true on the possibility, hey, it might be sorted, let's get out of there. And now we loop through the list. So 5 and 64 didn't need to be swapped, but guess what? 64 and 32 did. So we go in here, we set sorted to false, so we say, hey code, remember to go over it one more time after we're done, and switch that 64 with 32. I'll just print I'll print the list before it's swapped around so you guys can kind of see the before and after. Print list. And now when we run this code in our VS Code, as you can see, this is the old list and this is the new list. I'll just clear it up for you guys one more time. And there you go. Now, how would we do this if we wanted to do greatest to least? Well, that's simple. Instead of saying, hey, if the one before is bigger, switch it, we'll say, hey, if the one before is smaller, switch it. And then now let's run the code, see what happens. Oh, look at that. Now we're sorting from greatest to least. And there you have it. Now, I might have went through this a little too quick, and if so, feel free to leave any questions or concerns you have in the comments. This code, exactly what you're seeing, will be uploaded to the GitHub repository you'll find in the description below, so you can copy this code, test it out yourself. Again, any questions, any notes, anything you might want me to learn, explain further, feel free to leave in the comments below. I hope that I was able to help your understanding or teach you the bubble sort algorithm today. Thank you guys so much for watching. Have a great day.